Um, Thank you for that quick introduction about me. So thank you also Armada JS for inviting me here. My first time in Serbia, lovely place, and thank you also for attending here and going to listen something from me, learning something from me. Okay, let's start. There are people still coming. Okay, so you're here to listen and to learn something about Rust-based bundlers or JavaScript bundlers. Again, I'm from Philippines and now living in Oslo, Norway. And just to add something on the previous introduction about me, during the pandemic, I wrote some books because I don't have anything to do. Oslo was closed and couldn't go home back to Manila. So, yeah, I ended up writing and co-writing 3 books in total. So, okay, so this is a car design that shows you different pieces that were put together to build this car. Similarly, in software applications, these pieces are called modules, right? Uh, you can also say that in React, React components are the building blocks of a React application. So creating modules to build software or a car, gives benefits like number one would be isolation. So isolation allows people to work individually on the car or the application without delaying someone. Another one, composability. So clear boundaries for each individual component, and they're able to compose each piece together to create a fully functioning feature, right? Another one, reusability. Also, in reusability, we can reuse the same components. For example, in this car, would be the wiper, wheels, seats, etc. Right? So that's for the reusability. Another one, organization. So the effect of each individual piece having clear boundaries for how they interact with each other, right? So these are some of the benefits of this, creating modules. So how do we modularize our code before? So brief history. First is IFI. So if is immediately invoked function expression, it mimics a module scope, can hide variables, self-contained. It helped us create module pattern back in the days. So in this example of IFI, the X variable is not visible outside of the IFI. So trying to log it outside of the IFI results in reference error, right? Another one, back in the day, CommonJS, built for Node.js originally, and synchronous. AMD also came to help us. An example of AMD is require.js. So AMD fixes dependency resolution and pollution of the global scope, and we use CommonJS and AMD to share libraries through NPM packages that you normally use every day. So how do we use CommonJS in the browser if it's built for Node.js and synchronous? So through Browserify, Browserify is made to support CommonJS in browsers. It is a module bundler that reads all requires and module exports and bundle all JavaScript files into one bundle JS file. So you would see this commonly when you build your application, right? In this, for example, output folder, you would see this bundle.js. And it's normally in SPA or whatever JavaScript frameworks you're using. So Browserify needs Gulp and Grunt as task runners to help you build your application. And then we have Webpack. This is a module bundler that can do things more than what Browserify can do, such as it detects the code you don't use to exclude it while combining files, serialize the code and load it only when necessary, monitor file alterations, transpile code from ES6 to ES6, ES6 to ES5, or older version of JavaScript, etc. And it can concatenate multiple files together into single bundle for the browser. But the problem is that this process becomes increasingly slow as your app grows larger, right? That's a problem. And we're going to tackle that later, how to fix that. So I'm introducing to you Turbopack. This is written in Rust. This is a JavaScript bundler. The creator of Webpack, or the team who wrote Webpack, is behind this Turbopack, and now they're working for Vercel. So Turbopack delivers a swift and versatile development experience for developers or for application developers at any scale. And it has this progressive behavior and a lot of caching that you will see later. So why Turbopack? First is incremental by design. It knows which files to rerun because it has this a mechanism of caching, which you will see later. Ecosystem is friendly, you know. And this is typical in modern JavaScript bundlers nowadays. By default, it supports TypeScript, JSX, CSS modules, etc. And this is my favorite here, which is going to be your favorite, lightning fast HMR. So faster hot module reload than Webpack, no matter how big is the app. Meaning is O of one in terms of time and space complexity, right? No matter how huge the application is, the HMR is still the same as this millisecond. So if you work in old Angular project or React project that's really huge, and you have this, for example, not so powerful machine, you would notice that every time you change something, CSS or JavaScript or just string, you have to wait for 7 seconds, right? Or 8 seconds, which is not giving your customer the best quality of work you've been doing, because the tendency of developers is to check their mobile phone, go to their Instagram if there's like notification or email or your relatives or whatever, and then now you lost your concentration on building application. Okay, so in this Turbopack, it has built-in support for RSC or React Server Components. Of course, it's built by Vercel. What else? Simultaneous multiple environment targets. You can build and optimize for multiple environments together. Browser, server, edge, SSR, React Server Components. Okay, so Vercel is planning to use Turbopack to create a remote cache that would help developers have this single source of cache and distribute across the team. So the idea of this single source of cache is the whole team, all your colleagues, all the other developers. For example, your 5 front-end developers in one team. You have this cache from the cloud, and then the effect would be having this faster startup in your machine, because instead of rebuilding it on your local machine, you're reusing a cache that's already been done by your other developers, but it's stored in the cloud. So it's just a matter of like downloading the cache and then starting it in your local machine, which is a lot of help for us. What else can I say in Turbopack? It supports RSC, right, in Next.js 13. The problem with Turbopack is there's no support yet for server actions, and I'm going to explain that later. But again, why replace Webpack? So Webpack was created 10 years ago. It retains its dated architecture despite web development's significant growth. And it has these plugins, right, that can do anything, but now getting some problems like uh, backward compatibility would be challenging, and as it's risk breaking users' existing implementations. Cache invalidation is often too sensitive, causing extensive rebuilding when small changes are made. And in incremental builds, cache lookup helps skip redundant work, but with many modules, it can lead to considerable cache lookup costs. Okay, so let's go to Turbopack's architecture, so you'd understand what is this Turbopack under the hood. So Vercel created a learning system using Rust as the base for this Turbopack. Why Rust? Rust offers parallelism, more control over memory, memory allocation, and without it being as painful as C++ when you're writing C++, right? And in terms of security, it's safer, than C++, but it's more challenging to write than JavaScript. So to encourage plugin development, Vercel supports both JavaScript and Rust for plugin interfaces, and developers can start with JavaScript and then port it to Rust afterward. Next layer would be Turbo Engine. So this is just a core engine for common tasks like caching, invalidation, and incremental builds. And Vercel, instead of writing their own transpiler, Vercel is using SWC, modern transpiler built in Rust, that replaces Babel, and it's way faster than Babel. The next one, this is the bundler itself, the bundler handling CSS, static assets, WASM, images, fonts, and more leveraging SWC. And then, in the future, it will also support, the plan is to support other JavaScript libraries and frameworks. So going back to that server actions that Turbopack has no support yet, if you haven't used server actions in the new Next.js version, with server actions, you don't need to manually create API endpoints. Instead, you define a synchronous server function that can be called directly from your components, and you can query from the database. So it's good in the sense that you're writing front end, right? UI components, but you can use an ORM right away and query from the database, without using or without writing any REST API endpoints. So why Turbopack is so fast? Let's see. Turbopack has this impressive speed, and it is attributed to its incremental computation engine. So in a typical bundler, the process involves reading files, bundling them, right? Yep, I think you can see this. So again, reading files, right? Bundling them, and then concatenating them, and performing, for example, multiple tasks. However, Turbopack takes a different approach by keeping track of the inputs and outputs of each function. And during the first run, it reads, bundles, concatenates the files, and remembers all the outputs. But on subsequent runs, for example, if a specific file, such as this file here, sdk.ts, as you can see here, for example, it's modified, right? Turbopack only needs to redo the steps related to that file, to this file. And it doesn't need to read or bundle the unchanged file like this API.ts. So this is incremental computation, and the native speed of Rust are responsible for Turbopack's speed performance. And interestingly, the Turbo engine itself is not involved in the bundling process. its main function is to save the results of the function, so caching the output. So to get started, you just use this command, npx. It will download the latest version of Next.js with this Turbopack script. As you can see here, it will have this turbo flag, and there you go. Now you're running your Next.js with this Turbopack. I don't have any demo of this because it's just a bundle. You won't see any like effect or whatever. It's just rendering your application in the browser. So let's move to Rspack. So ByteDance and Valor Software introduced Rspack to the open source community. So ByteDance, by the way, is the company behind this popular application, TikTok, and they dog fooding this, meaning they're using this bundler in their own company, and they open source it for others to try. So Rspack is a fast Rust-based web bundler, same as Turbopack. It also has this fast startup, right? Lightning HMR, hot module reload. The difference between Rspack and this Turbopack is this Webpack compatible, where you don't have to relearn another plugin or another way to, for example, add some minification or optimization in your application. Once you know Webpack, you already know how to use Rspack because you can just copy paste, and you will see that later. And of course, batteries included. By default, it supports TypeScript, JSX, CSS modules, Sass, production optimizations, right? And framework agnostic, in the beginning. So you can use this in Vue.js and React and other JavaScript frameworks. So to get started with this, just use npm create Rspack at latest. It will give you the latest Rspack version. And then you have this script in your package.json says Rspack serve, and it will serve your application. And then here's a screenshot of this rspack.config.js, and you will see that very similar to Webpack configuration because it's fully compatible. But I would say right now it's just 90%. There's still working, make it 100% compatible, that you can copy your Webpack configuration. For example, create React app that you just ejected, and you have this configuration, right? It's normal, especially in old React projects where you would normally see ejected, CRA. So you can copy it, paste it in some editings, and it works. So you can reuse your Webpack skills. So these are the two new JavaScript bundlers written in Rust, but I edited this presentation, updated it, and I just want to share you this new JavaScript bundler, Bun. I can't help it. This is a hot topic right now. Just a quick overview. So Bun is an all-in-one JavaScript runtime and toolkit designed for speed, complete with bundler, test runner, and Node.js compatible package manager. But Bun is not written in Rust, it's written in Zig, which is a general purpose programming language and toolchain. So again, Bun, one-stop shop, package manager, so you can replace your NPM with Bun install. It also bundles your application, and again, it's like a runtime. Replace your Node.js with Bun. And this is their own benchmark, by the way. Way faster than ES Build, Rspack, Parcel, and Rollup and Webpack. But in Bun, it says here actually, this is from the docs. For example, in React, Bun can run that library, React. But Bun is not a framework, so you should use a framework like Vite to build an app with server-side rendering and hot reloading in the browser. It's just a runtime in this sense. And another thing that I noticed in Bun, it's only available on Linux and Mac OS users. Windows is not yet supported. But you can try it. It's really fast if you're using Mac. Now, I introduced to you two Rust JavaScript bundlers, but let's go to stable and battle-tested bundler. Since, for example, let's say you'll be creating a new project tomorrow, you would ask yourself, should I use this Turbopack or Rspack? Let's see. So here we have Vite. Vite again this is not written in Rust, but I want to introduce Vite if you haven't used this. Vite, which is written in Golang, was created back in 2009. This build tool has two major parts: a dev server and a build command, or you can also call it pre-configured bundle. As you can see here, the dev and the prod are separated. The dev server provides rich feature enhancement over native ES modules, extremely fast hot module replacement for instance. This is where you get this thing called O of 1, which it doesn't matter how large the application is, just going to give you this exact or same speed when you're getting this HMR. But in Vite, they not using ES build for bundling, so their current plugin API isn't compatible with using ES build as a bundler. In spite of ES build being faster, Vite's adoption of rollups, flexible plugin API, and infrastructure heavily contributed to its success in the ecosystem. So to give you an idea of what is this rollups, this is the bundler that Svelte framework is using before, but they shift to Vite also. So a quick summary before I get some Q&A. Turbopack and Rspack, both Rust-based bundlers, lightning fast HMR to avoid that developers looking on their phones when writing code, because they would see those changes right away on the screen. And Rspack has Webpack compatibility, while Turbopack does not have. Vite is the most mature bundler, which is what I would recommend you if you have new projects in the future or in the horizon, or if you want to convert your old Create React app, which uses Webpack under the hood, and you want to have this really good developer experience that when you see your changes while hitting the Control S or Command S on your keyboard, Vite is what I would recommend. So resources, Turbo, Buildpack, Rspack.dev, Vite.js.dev, and Bun. You should also see this Bun and try it. It's a really incredible tool. So yeah, thank you very much. And then you can ask me questions, whatever questions you'd like to know.